This video will review finding the sum of a series, and two different series will be looked at. The first series will be arithmetic, the second series will be geometric. So the first series says for 7 plus 11 plus 15 plus 19 plus and so on forever, find the sum of the first 60 terms. Well, we want to identify its pieces. Its first thing to note is that its start value a equals 7, and then its difference, which probably is painfully obvious, is going up by 4, or the difference is 4. If you couldn't see that, just take any number and subtract the one before it. 15 take away 11 is 4. The other thing we need to know to actually get started with the formula is what the n is. In this case, we're looking for the sum of the first 60 terms. So the formula is the sum of an arithmetic series is n times 2a plus n minus 1 times d all over 2. So we're looking for the sum of the first 60 things, and as I said, n equals 60 times 2a, which is 7, plus, first step was the formula, second step I'm just subbing in. 2 times 7, what's n? Put in brackets, 60 minus 1 times d, which is 4. It's a little bit of a large formula, but it's going to simplify really quickly. We get the sum of the first 60 equals 60 times 2 times 7, 14. 60 minus 1 is just 59 times 4 all over 2. I think I'll go up here now. So the sum of the first 60 things is 60 times, and let's do everything in the brackets there all at once now. Order of operations says do 59 times 4 first, and we get to 36 plus 14, and you get 250, and so now 250 goes in the brackets here, and don't forget, lots of people forget, still dividing by 2. And now I can do my very last step, which is just multiply those together. 60 times 250 equals, divided by 2, 7,500. It's sort of a word problem, so let's just cover our bases with a word answer and say the sum of the first 60 terms is 7,500. That was finding the sum of an arithmetic series. Now we're going to look at a geometric series. This series is 2,000 plus 1,000 plus 500 plus 250 and so on forever. Let's find the sum of the first 23 terms. Like before, we want to start with what we know. We know the starting number a is 2,000, and it's geometric, so we're looking for r, in this case the ratio, or the multiple from one number to another. And if you can't see it, a lot of students will get it wrong. They'll say, oh, it's 2, but it isn't. Take a number and divide by the one before it. If you still can't see it, what's 500 divided by 1,000? 0.5. In other words, these numbers are changing by multiplying by 0.5. Finally, we're looking for the sum of the first 23 numbers, so n is 23. Alright, well, the sum of a geometric series is calculated using the following formula. Sn equals a times r to the power of n minus 1 all over r minus 1. And we have those pieces. So we're looking for S23 equals 2,000 times 0.5 to the power of 23 minus 1 all over 0.5 minus 1. So we get 2,000 times, and let's do this in the bracket stuff all at once, 0.5 to the power of 23 equals, don't forget this step, it's 0.5 to the power of 23 minus 1. It makes a huge difference. You get negative 0.999999988 all over negative 0.5. Good to show that step, but from here we'll go right to our answer. Just one thing though, pretty good assumption to assume the calculator rounded there, we need a rounding dot. So now let's keep going. Take that, multiply by 2,000, and we get that, and divide by negative 0.5, and we get our final answer, 399.9999523. Another rounding dot because, again, the calculator probably rounded. And so we have here the sum of a geometric series, and we should probably put a word answer. Therefore, the sum of the first 23 terms is 3,999.999,523. So that was the sum of a geometric series, and both those examples together covered finding the sum of a series.